All right. Quadratics and complex numbers, which is probably one of the more difficult things we've done throughout the first semester. I'll take my time. I'll see. There's some of this we can do in the calculator for sure, but I'll do a lot of this stuff you can do without a calculator, so that's what we'll focus on the most. All right. So number one, just getting right into it. What number does I equal? So this is always the same thing. We talk about I a lot in this unit, but I is always equal to the square root of -1. Okay, I is always going to equal the square root of -1, no matter what, because the whole point of this is that you can't take the square root of negative. The square root of a negative is not possible. So that's why we call it I for imaginary. So we like to pretend that it exists. That's why we call it I. Square root of -1 is the answer to that. So number two, we're adding. So notice whenever you have the little plus sign here, okay, all you're going to do is combine like terms. So like terms, you got 5, and you're going to add 2 to it as well. So 5 and 2 are like terms. 5 plus 2 makes 7. And then you combine your I terms. -4i plus -3. So -4 plus -3 is -7i. So together you'd have 7 minus 7i. And that would be your answer to number 2. So again, just combine your like terms. Number 3 is another one where you just combine like terms. So you got 2 plus 7. 2 plus 7 makes 9. And then you've got 3i plus 1i. So 3 plus 1 makes 4i. So that would be 9 plus 4i. And number 4, you're subtracting. But be careful when you subtract, okay? Still like terms. So 6 minus 4. 6 minus 4 makes 2. And then your I terms. 8 minus 5. 8 minus 5 makes 3. So it'd be 2 and then plus 3i. It wouldn't be minus 3i because 8 minus 5 is still a positive 3. 8 minus 5 is positive 3. So this is plus 3. Okay. Number 5, again, kind of similar. Just be careful with all the negatives that are going on here. Combining like terms, 4 minus 2. 4 minus 2 is 2. And then -2 minus -6. So minus a negative makes that plus 6. So -2 plus 6 makes 4i. So you'd have 2 plus 4i. And then, so number 6, notice there's no more plus sign, no more minus sign. This is multiplying. And when you're multiplying, you're going to have to FOIL. So 3 times 2 will make 6. 3 times -i will make -3i. 4i times 2 would make 8i. And then 4i times -i. So 4 and -1 make -4. And then I and I make I squared. So you have to be very, very aware of the I squared here. So there's a couple things that happen. These I terms combine. -3 plus 8 makes 5i. So you're going to have 6 plus 5i since it is a positive 5 I get. But we have to remember that I squared, we talked about this a long time ago, I squared is always equal to -1. So this means I have -4 times -1 here, which -4 times -1 becomes a positive 4. There's no I left in this because we're converting it completely into a number. But it does change my sign from -4 to +4. So I've got 6 plus 4 that I can combine, and 6 plus 4 makes 10. So this would be 10 plus 5i as my final answer. So another one where you have to FOIL, but so again, be careful, especially when you get the I squared part. So 3 times 3 makes 9. 3 times -1i will make -3i. I times 3 makes positive 3i, and then I times negative I is going to be a negative I squared. So a lot of times people think, oh, those cancel out. They would cancel out if you were adding them, but you're not adding the i's here. You're I times I. You're multiplying those. So it's like 1 times negative 1 is still negative 1, but the I and the I together make an I squared. So negative 1 or negative I squared. So when you combine these, the negative 3i plus 3i, now these cancel because a negative 3 plus 3 is 0. So that's going to go away. And then remember, I squared is always equal to negative 1. So this is a negative still, but then I squared is negative 1, which converts this into plus 1. So our answer, 9 plus 1 to make 10. Very, very tricky. Not difficult, but certainly very, very tricky to get right. Very easy to get that one wrong. So number 8, I am going to rely plain and simple on the quadratic formula here. You can factor number 8. So if you're interested in factoring or feel good and comfortable factoring, by all means, go ahead and factor. But I am going to use the quadratic formula, because for some problems later on, I'm going to have to use the quadratic formula. So let me go ahead and write the problem out here. We have x squared minus 9x plus 20 equal to 0. So the first thing I need to point out is it has to be ax squared plus bx plus c equal to 0. That has to be the quadratic, the way it's set up for me to use my formula. So my formula is negative b plus minus square root of b squared minus 4ac, all divided by 2a. And make sure you plug those things in with parentheses as well when the time comes. So in this problem, my a value is 1. So a is equal to 1. My b value is negative 9, and my c value is 20. So I'm going to plug those numbers in to my quadratic formula. So I'll have negative b, now a negative 9. That'll make that a positive 9 for this negative b part, plus minus the square root b squared, so it's going to be negative 9 squared, minus 4 times a is 1, and times c, which is 20. All divided by 2 times a, and a is 1. So I'm going to use my calculator to simplify pretty much most of this here. Everything inside this radical sign, I'm going to type that in the calculator and see what I get. So let me go and jump to my calculator to work that out real quick. So my calculator, I'm going to type in not the square root. I'm going to leave the square root out for now. But I'm going to type in negative 9 in parentheses squared minus 4 times 1 times 20. So this is just the part that's inside the radical sign. I'm not including the radical sign in with this just yet. But when I type that all out, that equals 1. So back to my problem. Everything that's inside the radical sign, I have 9 plus, I'll go back to, I guess, using the orange. I still have 9 plus minus, but inside the square root, all of that just became 1. And then 2 times 1 at the bottom is 2. So now the question is, can I simplify the square root of 1? What can I do with that? And that's true, I can. The square root of 1 is just 1. So this next step, and now it is just 9 plus minus 1 over 2, because the square root of 1 is 1. If you don't believe me, type in the calculator. The square root of 1 is 1. So that's why I changed the square root of 1 to 1, as you can see there. So to finish this off, and I'm going to have to move it off to the side here because I kind of ran out of room. I have 9 plus 1 over 2, which makes 10 over 2, which means 5 is an answer. But I also have 9 minus 1 because it is plus and minus after all. So the plus and minus is there because it's combining two fractions in one. So The plus version makes 10 over 2, which is 5, and then 9 minus 1 over 2 makes 8 over 2, which is 4. So my answers are 5 and 4. Or 4 and 5, option 1. Again, number 9 is factorable, and I encourage you to factor it because it does take less time. But I'm going to use a quadratic formula. Again, because you'll see in future problems, not everything is factorable, but quadratic formula works on every single one. So I'm going to use the quadratic formula here. So here I have 2x squared minus 3x plus 2, or no, I'm sorry, minus 2 equals 0. So again, same formula, negative b plus minus square root b squared minus 4 times a times c, all divided by 2 times a. So now in this one, a is 2, b is negative 3, and c is negative 2. So make sure you're plugging those in with those negatives. So a negative b, a negative 3, will turn that into a positive 3 for that negative b part outside. So plus minus the square root b squared minus 4 times a times c, all divided by 2 times a. So there it is, everything plugged in. Now again, I'm going to use the calculator to work out all of this stuff inside the radical. So let me go ahead and do that real quick. That is going to be negative 3 squared in parentheses minus 4 times 2 times negative 2. Oops, hold on. Got to fix this. Negative 2. Enter, and that is 25. So let me go back to my problem. So I've got 3. Use the orange again. 3. Come on. Plus and minus still there, but everything inside the radical, all that just became 25. And 2 divided by 2 in the bottom is just 4. So moving this over here just for a little bit. 3 plus minus the square root of 25 over 4. Now, the square root of 25 is something I can simplify. I know the square root of 25 is just 5. So really, this is just 3 plus and minus 5 over 4. So again, if you don't believe me, go back to your calculator, type in the square root of 25, and you'll see it equals 5, a plain old simple 5. So that's why I've written down plus and minus 5. I've changed square root of 25 to just 5. And same as last time, I've got 2 fractions, 1 plus, 1 minus. I've got 3 plus 5 over 4, which makes 8 over 4. So that answer is 2, since 8 divided by 4 is 2. And the other one is 3 minus 5 over 4. 3 minus 5 is negative 2 over 4, which reduces down to negative 1/2. So negative 1/2 and 2 are your answers. Number 10, another one with the quadratic formula. So again, I'm going to go back and use that quadratic formula. It's going to be something that comes up quite a lot. X squared plus 5x plus 7. Now this one is not factorable, so you have to use a quadratic formula. So negative b plus minus square root b squared minus 4ac, all divided by 2a. So here a is 1. B is 5, and C is 7. So let's plug those in. So this would be negative 5 plus minus square root of b squared. B is 5, so 5 squared. Minus 4 times 1 times 7. That's your A and your C. Divided by 2 times 1, because 1 is A. So again, if I type all of this in my calculator, we'll see what we get. So in my calculator, I've got, in parentheses, 5 squared minus 4 times 1 times 7. And that is negative 3. So this is a little more interesting now because it's a negative number. So I have -5 plus minus, and inside the radical is -3. And on the bottom, 2 times 1 is just 2. So I'll move this back over here just so I have a little more space. Plus minus square root of -3 over 2. Now here's where it gets interesting because I can't really simplify the square root of a negative. That's an issue right now. And we talked about this. When we have a square root of a negative number, what you have to do is separate the negative from the number itself. So take the negative, pull it apart, call it -1 so that the negative can be with 1, and then have the 3 be positive. So what I do is I call the square root of -1, we call that I. We talked about that at the very, very, very beginning of the video. So that's going to turn the I, and the square root of 3, well, I can't simplify it still, so it still remains square root of 3. So I'm going to change that square root of -3 into I square root of 3. So when I write my problem back down, I still have -5 plus and minus, but instead of this, I'm going to have I square root of 3 over 2. And nothing there is going to reduce, so that should be my final answer. So I'll let you figure out which one of the answer choices it is, but yeah, there it is. Oh, well, I guess the answer choice is kind of there. Number 11, notice how there's no x term in the middle here. It's just 3x squared plus 48. You can still use the quadratic formula. Just use, since there is no b value, you just use 0 as b. But because there is no b value, because there's just a single x in this problem, I'm just going to solve it like a normal equation. So I'm going to subtract 48 on both sides. That's going to leave me 3x squared equal to -48. Then I'll divide by 3. And that leaves me x squared equal to -16. And then to get rid of the squared, I'll square root it. So that gets rid of the squared, leaves me with x, and the square root of -16. Now this is interesting because remember, you got the negative. So you separate the negative from the 16. Remember, we call this I, and the square root of 16 is 4. So this is going to become a positive and negative 4i. So again, I chose to do it like a normal equation because there's only one x in this equation. I don't have any other x's. It's simply that. And when it's all by itself like that, well, then I can get it all by itself like this. Move everything else to the other side and solve like a normal equation. Number 12, I can do the exact same thing because it has x all by itself again. There is only one x in that problem. So it'll make things a little bit more simple. So we have x plus 1 squared and minus 4 equal to 0. So the first thing I'm going to do is move the 4 over. That's going to mean that x plus 1 squared equals 4. And now I can't get into this 1 until I get rid of the square because it's inside the parentheses. So I need to get rid of the squared first. So I'm going to square root both sides to get rid of the squared. Leaves me with x plus 1, no longer needs parentheses because it's no longer being squared, equal to the square root of 4. Now here's what gets interesting. The square root of 4 is a positive and -2. That's probably the part that's going to confuse you guys the most, I realize. So listen to me carefully. It's one of those rules we talked about a long, long time ago. When dealing with equations, whenever you square root something in your equation, you have to make sure you convert it into a plus and minus. The reason is because when you square root 4, you're asking, well, what number could I square that would equal 4? In that case, there are two numbers. 2 squared equals 4, and -2 squared equals 4. So we have to count for both those numbers. So that's why it equals both +2 or -2. It could be either one. So this is where it gets interesting because x plus 1 is equal to both +2 and -2. So if you want to figure out what x is, you have to figure out which version of x makes it +2 And then which version of x makes it negative 2? So in that case, it would be 1. If x was 1, you'd get the positive 2 version, and that's a solution. And if x was negative 3, that creates the negative 2 version. Now, if you plug in both of those numbers in for x, if you plug in 1 for x, it should work out. And if you plug in negative 3 for x, it should also work out. So you can double check your answer by plugging it in. 1 plus 1 squared minus 4. 1 plus 1 is 2, and 2 squared minus 4 equals 0. That's 4 minus 4 equals 0, which is true. And if you plug in negative 3 plus 1 squared minus 4 equals 0. Negative 3 plus 1 is negative 2. And negative 2 squared is positive 4, and 4 minus 4 equals 0. So that's true. So both plugging in 1 and plugging in negative 3 worked, just to make sure. But it is something you really have to get in the habit of remembering, is putting a plus and minus there after you square root something. Number 13 and 14 are back in the quadratic formula. So I guess we'll do both of those. So with number 13, x squared minus 11x equal to 12. Here's the thing. It has to be, as you remember, ax squared plus bx plus c equal to 0. So I've got to move the 12 over. So subtracting 12 will do the trick. That gets me x squared minus 11x minus 12 equal to 0. So now I know a is 1, b is negative 11, and c is negative 12. So I'm going to use that in my quadratic formula. So that's going to become negative b will be a positive 11 plus minus square root of negative 11 squared minus 4 times 1 times negative 12, all divided by 2 times 1. So when I type all this in my calculator, and I'm talking about the stuff inside the radical sign, let's see what that gets me. I'll have 11 plus minus, well, let's see what's inside that radical. So it's, let's clear this. In parentheses, negative 11 squared minus 4 times 1 times negative 12. And that equals 169. So back to my problem. So I have 169 inside the radical sign. On the bottom, 2 times 1 is 2. Now, this simplifies. You can type this in the calculator, but I already know the 169, square root of 169 is 13. So that's going to be 11 plus and minus 13 over 2. Now, again, if you don't believe me, well, type it in for yourself. The square root of 169 equals 13. So that's why I've changed it to 13. And now I've got two equations. I got one for plus, one for minus. So 11 plus 13 over 2, which is 24 over 2, equals 12. And then I've got the minus 13. 11 minus 13, that's going to be negative 2 over 2, which equals negative 1. So 12 and negative 1 are your answers. So number 14, another quadratic formula. Again, we'll just sort of cut to the chase. I'm just going to go ahead and write the formula. So the formula would be a positive 6, because a negative b will turn into a positive there, plus minus the square root, negative 6 squared minus 4 times 2 times negative 3, all divided by 2 times 2. So that's just plugging in the a, b, and the c. If you skipped ahead in the video to get to this problem, then watch previous problems, because I just trying to save a little bit of time. So if you're wondering the explanation on any of those, go back and watch. But it just plugs in the A, B, and the C. So now I'm going to type in my calculator everything that's inside this, and we'll see what that gets me. So I'll have 6 plus minus, and then we'll see what's inside the square root. So I'm going to have negative 6 in parentheses squared minus 4 times 2 times negative 3. which equals 60. So this is one that gets a little more fun. So I'm going to have 60 inside the radical. And then 2 times 2 at the bottom is 4. So here's the thing. With the square root of 60 is it's not a perfect square. If you try to work it out, it'll give you a decimal. Like type it in the calculator, square root of 60. Oops. Try it again. Square root 60 is a decimal, so it's not useful to me because it's not a perfect square. So remember how you simplify things that are not perfect squares. You try to figure out one of the perfect squares, so 4, 9, 16, 25, 36, 49, etc. Which one of these will divide evenly into 60? 49 doesn't, 36 doesn't, 25 doesn't, 16, you can try it. If you're unsure of what works, take 60, divide it by those perfect squares like 16, see if it works. 16 doesn't work, gives me a decimal. So then I could try dividing it by 9, because 9 is another perfect square, and another decimal. So I got one more to check. 60 divided by 4 is 15. So 4 works. 4 is a perfect square that divides into 16. 4 times 15 makes 60. So simplifying this, the square root of 4 is 2, and the square root of 15, well, that's the leftover part. That's not going to simplify anymore. So square root of 60 becomes 2 square root of 15. So 6 plus minus, no longer this, but 2 square root of 15 over 4. And my answer, I can reduce, notice how I can reduce 6, 2, and 4. All three of these numbers are divisible by 2. So if you divide each of these by 2, then your answer is going to become 3 plus minus 1 square root of 15, or just square root of 15, over 2. 6 divided by 2 makes 3. 2 divided by 2 makes 1, which isn't written there, but it's still there. And then 4 divided by 2 makes 2 at the bottom. All right. So complex conjugate, this is pretty simple. Complex conjugate just means opposite. So the real part stays the same, but the imaginary part changes. So the complex conjugate would be negative 6 minus 4i instead of plus 4i. So that's all there is for conjugate. Number 16. Which expression is equivalent to this? So here, let's go back. This is the last one. This is the last one. Okay, cool. Let's go ahead and divide this. I'll show you how to divide it again if you forgot. So we have 4 plus 3i over 3 minus 2i. So what you have to do is you have to multiply, because you're not actually going to divide anything here. You're going to multiply both the top 4 plus 3i and the bottom 3 minus 2i by the conjugate of the bottom. So the conjugate of 3 minus 2i is 3 plus 2i. So we're going to multiply the top and the bottom by 3 plus 2i. So when I multiply the top together, the top is 4 plus 3i, and I'm multiplying it with 3 plus 2i now. So I have to FOIL that. 4 times 3 makes 12. 4 times 2i makes 8i. 3i times 3 makes 9i. And then 3i times 2i, be careful, makes 6i squared. So this becomes 12. I can combine the 8 and 9 to make 17i. But the real trick is remembering that I squared is the same as negative 1. So what I have here is 6i squared is 6 times negative 1. And 6 times negative 1 makes negative 6. So 12 minus 6 is 6. And then I bring down my plus 17i. So that's my numerator. My numerator is 6 plus 17i. What's my denominator, though? So with my denominator, I'm just going to erase some of this. My denominator, remember, is 3 minus 2i. And I'm multiplying it with 3 plus 2i. So FOIL it. 3 times 3 is 9. 3 times 2i is 6i. Negative 2i times 3 is negative 6i. and then negative 2i and positive 2i. Negative 2 times, remember you're multiplying these. Negative 2 times 2 is negative 4. I and I makes I squared. Remember, I squared is negative 1. So 6i minus 6i is going to cancel. Those disappear. You get 9. Just bringing the 9 down. Negative 4 times negative 1 makes a positive 4. And 9 plus 4 makes 13. So my denominator is 13. So my answer will be option 1. It's got my 6 plus 17 on top, and it's got the 13 in the denominator. All right, that's going to cut it. I'll do some of these in a calculator, but not everything in a calculator, but I'll see what I can do. And I'll see you guys later. Bye.